Hey guys, this is Sakshi back and I welcome you all to my edutech platform, Better Learn. So, we are back to solve some more PYQ's problem from differential equations and we have already solved 6 problems. Hope you all got those solutions very well. So, please keep practicing those and let us see the 7th problem, which is from CSIR December 2016. Okay, so here you will have to frame a differential equation. So frame a easy one. Do not go to a difficult one. So a ball of mass m is dropped from a tall building with zero initial velocity. In addition to gravity, the ball experiences a damping force in the form of minus gamma v, where v is the instantaneous velocity and gamma is a constant. Given the values of m, gamma, and g, the distance traveled in time t in seconds is. So options given, and this is the question. So basically, when a ball of mass m is dropped from a building, obviously the first force you will write is equal to ma, and along with the gravity, it is also experiencing the damping force, right? Which is given by minus gamma v. So it is also experiencing uh, the gravity along with minus gamma v. Okay, so now I can relate this both. I can equate this forces ma equal to mg minus gamma v. But here, in order to form a differential equation, I'm going to write a as dv by dt, which is change in velocity. Change in velocity is acceleration, right? So I'm going to write that. Okay. So now divide the equation by m. So you will get dv by dt is equal to g minus gamma v by m. Okay, so dv by dt is equal to gamma v by m. Sorry, uh, this is plus equal to g. Right, now we know that m is equal to 10, gamma is equal to 10, and g is equal to 10. I'm going to substitute that. Uh, so on substituting, my gamma and m will get cancelled and g will be 10. So my equation will now turn to dv by dt plus v equal to 10. Now this is a very simple non-homogeneous, simple non-homogeneous differential equation and of first order. So first order differential equation, which is of the form dv by dy by dx plus p of x is equal to q of x. Okay, p and q can be constants. Okay, so now from this equation I can write my p to be 1 and q to be 10. And I have to find the integral factor, which is e power p dx. E power integral p dx will be e power x. So my integrating factor will be e power x. Sorry, this is dt over here because we are using dv by dt. Okay, see the integrating factor will be e power t. Now I'll have to find the solution, which is y into integrating factor into integral integrating factor into q, which is 10 dt plus c. Okay, so on doing that again, sorry, this is not y, this is v. Okay, now we will get the solution to be v e power t t. Okay, this is 10 into e power t will be 10 e power t plus c. So now you will think there is no condition given. How would we find the constant of integration? So we have seen that a ball of mass m is dropped from a tall building with zero initial velocity. So initially the velocity is 0. So that at time t equal to 0, the velocity will be 0. Hence you can write 0 e power 0 is equal to 10 e power 0 plus c, which will give you 0 is equal to 10 plus c. C will be minus 10. Okay, so now you can substitute this in the solution. So now your solution will be 10 minus 10 by e power t. Now again, the distance traveled is asked, right? So the distance traveled is, sorry, the distance traveled will be dx by dt. So this will be dx by dt equal to 10 minus 10 by e power t. So again, now I'm going to integrate everything. So I'm going to get x of t is equal to 10t plus 10 by e power t plus c. Okay. Again, we will use the same condition, which is at t is equal to 0, x will also be 0, because at time t equal to 0, x will not move. Distance will be 0. It will be the same distance. So now we are going to substitute over here. So 0 is equal to 10 into 0 plus 10 by e power 0 plus c, which is equal to 0 is equal to 10 plus c. Again, c will be minus 10. So on substituting in the solution, you get 10 into 1, t minus 1 plus e power minus t. So this is the distance travel. This is equal to option B. So I hope you get this solution. So this is the next question from CSIR June 2017, and this is also a very basic question, that is first order differential equation. So first order differential equations are very easy to solve. You'll just have to put the conditions given, that's all. So again, x dy by dx plus 2y is equal to cos pi x by x. So in order to form a differential equation of the known form, we'll have to divide it by x. So the equation will become so p of x is equal to 2 by x. P of x is equal to, okay. So now again the same thing, integral factor will be equal to e power p dx. P is 2 by x, e power 2 ln x, which can be written as e power ln x squared. So integrating factor will be x squared. Now I can write the solution as y into integrating factor is equal to integral integrating factor into q, which is cos pi x by x squared dx plus c. We'll have to integrate cos pi x, which is sin pi x plus c by pi. Okay, now we'll have to find c. So it is given that at x is equal to 1, y will be 1. X is equal to 1, y will be 1. So 1 is equal to sin pi by pi plus c. Sin pi is 0, so therefore c will be 1. Okay, so now I can write this equation as y x squared is equal to sin pi x by pi plus 1, and also this sin pi will go to 0. Okay, sin pi is 0 anyways, so this term will vanish. equal to 0. Okay, so I can write my y as 1 by x square. Okay, so now we'll have to find at x is equal to what is the value of y. So at x is equal to 2, y will be 1 by 4. Very easy, right? So now let us see the ninth question, which is from June 2018. Okay, so now here this is a second order differential equation, but before that we'll have to see if we can get any kind of form, like is this a known form of differential equation or not. So d square x by dt square plus 1 by x dx by dt the whole square minus dx by dt is equal to 0. This is not of a known form. So we'll have to bring this to a known form. Now I'm going to use this again, the UV method. So I'll be getting x d square x by dt square plus dx by dt the whole square. So on dividing this particular equation by this equation by x, I'll get 1 by x d by dt x dx by dt, which will be equal to d square x by dt square plus 1 by x dx by dt the whole square. Okay, so now this term can be written as this term. So I can write the first term, that is the first root term, as 1 by x d by dt x by dx by dt. Okay, so now if you see again, you are not going to get any known form of the differential equation, right? So let us see, like if we can change the form or not. So over here, I am going to consider y to be x dx by dt. Okay, so now my equation will change as so this is my new equation. So this can be of some form, right? So I can just rewrite this equation as dy by dt minus y equal to 0. Now this is of some form, like I can write this as dy by dt equal to y. So dy by y equal to dt, separation of variable separation method. So ln y is equal to t plus ln c. Wherever you have a logarithmic term after integration, you will use the constant as logarithmic constant. Okay, ln c, you will use ln c over there. You will not just use plus c. Okay, on simplifying this, you are going to get c e power t. Okay, so now I know that y is equal to x d by x dx by dt. Now I'm going to substitute x dx by dt is equal to c e power t. So again, integrating, so we'll be getting x square by 2 is equal to c1 e power t plus c2. I'm assuming this to be c1. Okay, Now this is the solution of x. In the question, we have given that t is equal to 0, x is equal to 0, and at t is equal to 1, x is equal to 1. So at t is equal to 0, x is equal to 0. At that time, you will get c1 to be 0. Sorry, c1 plus c2. You will have c1 plus c2. And at t is equal to 1, x is equal to 1. So you will have 1 by 2 is equal to c1e plus c2. From this, I can write that c1 is equal to minus c2. Now I am going to use that c1 is equal to minus c2 in over here, that is half minus c2 e plus c2. So half is equal to c2 into 1 minus c. So c2 will be 1 by 2 into 1 minus c, and c1 will be minus 1 by 2 into 1 minus c. We'll just have to substitute in the solution. So x square by 2 is equal to minus 1 by, what is the solution? c1 e power t. And then plus c2. This is for x square. Now we'll have to find at t is equal to 2, what is x? So t is equal to 2. Again, x will be, that is x square over here will be 1 minus e square by 1 minus c, which can be written as 1 minus c into 1 plus c, just a square minus b square formula. So at t is equal to 2, x square will be 1 plus e and x will be root over 1 plus c. So the option is root over 1 plus e, which is option C. So I hope you get the solution. This is a lengthy problem, but you'll have to think in a simpler way. Do not go for don't go in a very lengthier way. Try to simplify as much as possible. So I'm sure that the solution will help you a lot. So thank you. Like my videos, share my videos if you like them, subscribe, and also hit the bell. Do not forget to hit the bell. We'll see you tomorrow. Ta-da!